This is part of exam 4 college algebra. We solve system of equations using Gauss-Jordan elimination, reduced row echelon form. We'll look at one solution, no solution, infinitely many solutions. We solve manually 2 variable and 3 variable system of equations and verify the solutions using technology TI-84+. Also, we will solve 9 extra 2 variable, 3 variable and 4 variable system of equations using technology TI-84+. The last problem will be 10 variable system of equations that we will solve manually and verify with technology TI-84+. 2 variables system of equations have one solution when the 2 lines intersect each other at one point. 2 variable system of equations have no solution when the 2 lines are parallel to each other. 2 variable system of equations have infinitely many solutions when the 2 lines are identical or they overlap. 3 variable system of equations have one solution when the 3 planes intersect each other at one point. 3 variable system of equations have no solution when the 3 planes intersect each other but not at one point, or the 3 planes are parallel to each other. 3 variable system of equations have infinitely many solutions when the 3 planes intersect each other at one line, or when the 3 planes are identical, that is, they overlap. Then we'll solve linear programming graphic method. This is a word problem about carpenter that wants to maximize profit. The carpenter that makes bookcases and desks that wants to maximize the profit. We'll graph feasibility region and we'll find the maximum profit at the feasibility region, inside the feasibility region.
Ba 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 optimization problems in mathematics. An optimization problem may involve finding maximum profit, minimum cost, or maybe minimum use of resources. Optimization problem is to find the optimum solution subject to constraints of the given problem. Optimization problems solved in mathematics. There are optimization techniques. What is linear programming?
This is exam 4, test 4 review, detailed solution, college algebra. In this exam 4 review, we'll look at Gauss-Jordan elimination to solve system of equations such as 2x minus y plus 4z equals minus 3, x minus 2y minus 10z equals minus 6, 3x plus 4z equals 7. We're going to convert this into matrix. For x, we have 2, 1, 3. For y, it's minus 1, minus 2, 0. For z, it is 4, minus 10, 4. Augmented with minus 3, minus 6, 7. Then we're going to do Gauss-Jordan elimination, reduced row echelon form, which is 1, 1, 1 in the diagonal, 0 above the diagonal and 0 below the diagonal. And the result is A, B, C. That means x equals A, y equals B, C, z equals C. So when we work on this on Gauss-Jordan elimination, we'll end up at reduced echelon form, which is 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, and the result is 3, 7 minus half. That is x equals 3, y equals 7, and z equals minus half is the solution. Then we'll create this matrix in TI-84 plus. We'll call it matrix A. Then we're going to take ref of A to solve this matrix in technology. Then that will give us 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal. Then 3, 7 minus half, that is x equals 3, y equals 7, and z equals minus half. Then we're going to do linear programming graphic method. This linear programming is a word problem about carpenter maximizing profit. The carpenter that makes bookcases and desks, that carpenter will make X bookcases and Y desks to maximize the profit. From each bookcase, he will make $40 profit. From each desk, he will make $75 profit. That means the objective function is profit equals 40x plus 75y, and this is to maximize this profit. Subject to constraint. For woodworking, he has only 600 hours available. That means he's going to use 600 hours or less. That is 5x plus 10y is less or equal to 600. And for finishing, he has only 240 hours available. That is, he's going to use 240 hours or less for finishing. That is 4x plus 3y is less or equal to 240. Then he has to produce 0 or more bookcases, and he has to produce 0 or more desks. And we'll use this constraint to graph the feasibility region. We'll graph these two constraints are these two lines, and he has to produce more than 0 or more than bookcases, which is x is 0 or more, that is above the x-axis, and he has to produce 0 or more desks, that is y is equal or greater than 0, that is to the right of y-axis. Then this is the feasibility region. He has less or equal than 600, that is below this graph line, and he has less or equal 240, and that is below this line, then this is the feasibility region. Every point in the feasibility region is a profit. The maximum and minimum profit, they lie at the corner of the feasibility region. Therefore, we're going to evaluate the objective function, which is the profit, at the corners of the feasibility region to find the maximum and minimum profit. And it happened to be XY, which is X is bookcases, Y is desk. He has to produce 24 bookcases and 48 desks to get a maximum profit of 4,560. That is, the carpenter shop will make a maximum profit of 4,560 when 24 bookcases and 48 desks are produced and sold. So this is exam 4 test 4 review, college algebra. This is additional review to your professor instructor exam test review, which should be your main essential review. This is STEM engineering college algebra. This exam 4 review tutorials is good for students in college algebra, business math, development math, intermediate algebra, high school algebra 1 and 2. To prepare for development math algebra support, watch my development math exam 4 test 4 review video. In addition to this, I'm sharing this with you only as additional help, in addition to your professor instructor exam test review, which should be your main essential review. Number 21 is Gauss-Jordan Elimination. Solve the system of equations using Gauss-Jordan Elimination, that is, create the augmented matrix, perform elimination to reduced row echelon form, that is, ones in the diagonal, 0 above and below the diagonal, and the result is AB. That means x equals A, y equals B is your final solution. So this is 2x plus y equals 1, 3x plus 2y equals minus 2. Then we're going to create a matrix that is x is 2, 3. For y, it is 1, 2, augmented with 1 minus 2. Then the first thing is we're going to turn the 2 to 1, divide row number 1 by 2. 2 divided by 2 is 1. 1 divided by 2 is half. 1 divided by 2 is half. And keep row number 2 as it is. Then we're going to turn this to 0. To turn this to 0, keep row number 1 as it is, 1 half half. Then multiply row number 1 by minus 3 and add it to row number 2. So that is minus 3 times 1 is minus 3, minus 3 plus 3 is 0. Minus 3 times half is minus 3 over 2, plus 2 is half. Minus 3 times half is minus 3 over 2, minus 3 over 2 minus 2 is minus 7 over 2. Now we're going to change this, to 1, multiply row number 2 by 2, and keep row number 1 as it is. So that is 1 half and half, then 2 times 0 is 0. 2 times half is 1. 2 times minus 7 over 2 is minus 7. Then we're going to change this to 0. To change this to 0, you're going to keep row number 2 as it is, 0, 1, minus 7. Then you're going to change this to 0. So you're going to multiply row number 2 by minus half and add it to row number 1. So this is 0, 1, minus 7. Minus half times 0 is 0. 0 plus 1 is 1. Minus half times 1 is minus half. Minus half plus half is 0. minus half times minus 7 is 7 over 2. 7 over 2 plus 1 over 2 is 8 over 2. 8 over 2 is 4. So that is 4. So now this is reduced row echelon form. We have 1 in the diagonal and 0 above and below the diagonal. That means 1, 1, 0, 0. That means x equals 4 and y equals minus 7. That is x times 1 is x, 0, y times 0 is 0. That is x equals 4. X times 0 is 0, y times 1 is y, that is y equals minus 7. The solution is then xy equals 4 minus 7. X is 4, y is minus 7. 22 is another Gauss elimination. Solve the system of equation using Gauss elimination. That is, create the augmented matrix, perform elimination to row echelon form, which is 1, 1 in the diagonal, 0 below the diagonal, and the A above the diagonal, B, C. Note when 0 equals 0 means infinitely many solution, and 0 equals a constant K means no solution. So this is minus 2x plus 6y equals 3, x minus 3y equals 8. Then we're going to put this converted into matrix. For x is minus 2, 1. For y, 6 minus 3, augmented with 3, 8. Then we need 1 at the top, so simply interchange row 1 and 2. Then that row 1 is now 1 minus 3, 8. And row 2 is minus 2, 6, 3. Then we're going to eliminate minus 2 to 0. Then keep row number 1 as it is, 1 minus 3, 8. Multiply row number 1 by 2 and add it to row number 2. So that is 2 times 1 is 2. 2 minus 2 is 0. 2 times minus 3 is minus 6. Minus 6 plus 6 is 0. 2 times 8 is 16, 16 plus 3 is 19. This means you have 1 minus 3, 8, 0, 0, 19. So this is x times 0 is 0, y times 0 is 0, that means 0 equals 19. And this is false. Of course, 0 is not equal to 19. It is false. That means no solution. And that is what it says here. When 0 equals some constant, which is 0 equals 19, that is no solution. Number 23 is another Gauss elimination. Solve the system of equation using Gauss elimination. That is, create the augmented matrix, perform elimination to row echelon form. That is 1 in the diagonal, 0 below the diagonal, and the A above the diagonal, and the result is BC. Note 0 equals 0 means infinitely many solution, and 0 equals K constant means no solution. So the equation is, the system is 3x minus 9y equals minus 6 minus 2x plus 6y equals 4. And we're going to convert this to matrix. For x you have 3 minus 2, for y minus 9, 6, augmented with minus 6, 4. So we need here 1. If you multiply row number 1 by, if you divide row number 1 by 3 and keep row number 2 as it is, then 3 divided by 3 is 1, minus 9 divided by 3 is minus 3, minus 6 divided by 3 is minus 2. And keep row number 2 as it is, minus 2, 6, 4. Then we need 0 below 1. Then we're going to multiply row number 1 by 2 and add it to row number 2. So keep row number 1 as it is, 1 minus 3 minus 2. Then 2 times 1 is 2, 2 plus minus 2 is 0. 2 times minus 3 is minus 6. Minus 6 plus 6 is 0. 2 times minus 2 is minus 4. Minus 4 plus 4 is 0. So here notice you have 0, 0, 0. So that means you have x times 0 is 0, y times 0 is 0, and that is equal to 0. That is 0 equals 0. That means you have infinitely many solutions. To get those infinitely many solutions, so let y equals y will be independent variable, then x is going to depend on y. That is x minus 3y equals minus 2. That means x equals 3y minus 2. So the infinitely many solution xy is x is 3y minus 2 and y is just y, where y is from minus infinity to infinity. Now let's look some of the values. So for example, if y is minus 100, is from minus infinity to infinity, if y is minus 100, then xy is, x is 3y minus 2, y is y, that is y is minus 100, and the x is 300 minus 300 minus 2, which is minus 302. When y is minus 2, y is minus 2, x is 3 times minus 2 is minus 6, minus 6 minus 2 is minus 8. When y is minus 1, x is 3 times minus 1 is minus 3, minus 3 minus 2 is minus 5. When y is 0, then x is 3 times 0 minus 2, which is minus 2. When y is 1, then x is 3 times 1 minus 2, which is 1. When y is 2, 3 times 2 is 6, 6 minus 2 is 4, then x is 4. When y is 100, then 3 times 100 is 300, 300 minus 2 is 298. Then you go to infinity with the negative and to infinity with the positive. And that is infinitely many solutions. Number 24 is another Gauss-Jordan elimination. So use Gauss-Jordan elimination to solve the following system. Except this one is 3 variables, 3 unknowns, and 3 equations. That is 2x minus y plus 4z equals minus 3, x minus 2y minus 10z equals minus 6, 3x plus 4z equals 7. So we're going to convert this to matrix. So for x you have 2, 1, 3. For y minus 1 minus 2, 0. For z 4 minus 10, 4. Augmented with minus 3 minus 6, 7. And our goal is to do Gauss-Jordan elimination and to convert this to reduced echelon form, which is once in the diagonal, 0 above the diagonal and 0 below the diagonal, and the result is ABC, which is x equals A, y equals B, z equals C. So the first thing is we need 1 at the top. So we can interchange row number 1 and number 2. Then that will give us row number 1 will be 1 minus 2 minus 10 minus 6. Row number 2 will be 2 minus 1, 4 and minus 3. And row number 3 will be as it is, 3, 0, 4, 7. Then we need 0 below 1, 0, 0. So we need to turn this to 0, we need to turn this 0. And to do that, multiply row number 1 by minus 2 and add to row number 2. Multiply row number 1 by minus 3 and add it to row number 3. And keep row number 1 as it is. So that is 1 minus 2 minus 10 minus 6. Minus 2 times 1 is minus 2. Minus 2 plus 2 is 0. Minus 2 times minus 2 is 4. 4 minus 1 is 3. Minus 2 times minus 10 is 20. 20 plus 4 is 24. Minus 2 times minus 6 is 12. 12 minus 3 is 9. Then turn this to 0. Minus 3 times 1 is minus 3. Minus 3 plus 3 is 0. Minus 3 times minus 2 is 6. 6 plus 0 is 6. Minus 3 times minus 10 is 30. 30 plus 4 is 34. Minus 3 times minus 6 is 18. 18 plus 7 is 25. Then you have 1, 0, 0. Then you need to turn this to 1. To turn this to 1, simply multiply row number 2 by 1/3 or divide it by 3. So then keep row number 1 as it is, 1 minus 2 minus 10 minus 6. Row number 3 as it is, 0, 6, 34, 25. Then row number 2, 0 divided by 3 is 0. 3 divided by 3 is 1. 24 divided by 3 is 8. 9 divided by 3 is 3. Then you have now 1, 0, 0, 1. So now we need to turn this to 0. To do that, keep row number 1 as it is, 1 minus 2 minus 10 minus 6. Keep row number 2 as it is, 0, 1, 8, 3. Then multiply row number 2 by minus 6 and add it to row number 3. Minus 6 times 0 is 0. 0 plus 0 is 0. Minus 6 times 1 is minus 6. Minus 6 plus 6 is 0. Minus 6 times 8 is minus 42. Minus 42 plus 34 is minus 14. Minus 6 times 3 is minus 18. Minus 18 plus 25 is 7. Then you have now 1, 0, 0, 1, 0. Then you need to turn this to 1. Simply multiply row number 3 by minus 1 over 14 or divide row number 3 by minus 14. So keep row number 1 and 2 as they are. 1 minus 2 minus 10 minus 6. 0, 1, 8, 3. Then divide 0 divided by minus 14 is 0. 0 divided by minus 14 is 0. Minus 14 divided by minus 14 is 1. 7 divided by minus 14 is minus half. Now we have this in row echelon form. 1, 1, 1 in the diagonal, zeros below the diagonal, and A, B, C, some numbers above the diagonal. The result is minus 6, 3, minus half. So from here it is, this is row echelon form. So here we can do back substitution to solve it from here. Z is minus half and back substitute to get X and Y. But if you continue, then you get it to reduced row echelon form. And that is, we're going to turn this to 0, this to 0, this to 0. To do that, we're going to turn first 8 to 0 minus 10 to 0. To do that, keep row number 3 as it is. Multiply row number 3 by minus 8 and add it to row number 2. Multiply row number 3 by 10 and add it to row number 1. And that is 0, 0, 1. You keep row number 3 assets is 0, 0, 1 minus half. Then minus 8 times 0 is 0, 0 plus 0 is 0. Minus 8 times 0 is 0, 0 plus 1 is 1. Minus 8 times 1 is minus 8, minus 8 plus 8 is 0. Minus 8 times minus half is 4, 4 plus 3 is 7. Okay, then multiply row number 3 by 10 and add it to row number 1. 10 times 0 is 0, 0 plus 1 is 1. 10 times 0 is 0, 0 minus 2 is minus 2. 10 times 1 is 10, 10 minus 10 is 0. 10 times minus half is minus 5, minus 5 minus 6 is minus 11. So now we have 1 in the diagonal, 0 below the diagonal, then you need to turn this to 0. To turn this to 0, simply multiply row number 2 by 2 and add it to row number 1. So keep row number 3 as it is, 0, 0, 1, half. Keep row number 2 as it is, 0, 1, 0, 7. Then multiply row number 2 by 2. 2 times 0 is 0, 0 plus 1 is 1. 2 times 1 is 2, 2 minus 2 is 0. 2 times 0 is 0, 0 plus 1, 0 is 0. 2 times 7 is 14, 14 minus 11 is 3. Now we have reduced echelon form, where you have 1 in the diagonal, zeros below the diagonal, and zeros above the diagonal. And the result is 3, 7 minus half, that is x equals 3, y equals 7, and z equals minus half. You can create a matrix called A, which is 2, 1, 3, minus 1, minus 2, 0, 4, minus 10, 4, minus 3, minus 6, 7, and this is in TI-84 plus. You create this matrix, then use ref A to get the solution. So the solution is 1, 0, 0, 0, 1, 0, 0, 0, 1. The result is 3, 7 minus half, which is x equals 3, y equals 7, z equals minus half. I have an application, I have a video on system of equations on applications. Please watch that video. I have several applications where I solve system of equations using TI-84 plus. Number 25 is linear programming graphic method. Linear programming is a mathematical modeling technique in which linear functions is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, and in social and physical science. In business maths, we analyze both graphical method and simplex method. In this exam review, we will analyze graphic method. The application is maximizing profit. Dovetail Carpentry Shop makes bookcases and desks. Each bookcase requires 5 hours of woodworking and 4 hours of finishing. Each desk requires 10 hours of woodworking and 3 hours of finishing. Each month, the shop has 600 hours of labor available for woodworking and 240 hours for finishing. The profit on each bookcase is $40 and on each desk is $75. How many of each product should be made each month in order to maximize the profit. What is the maximum profit? So the first thing is we need to convert this, the word problem, we're going to convert it into a table. We have two products, bookcases and desks, and we don't know how many bookcases and how many desks we need to make to maximize the profit. So we're going to call them X bookcases and Y desks. Then the woodwork for the bookcases requires 5 hours and the finish requires 4 hours. And the profit is $40 each bookcase. And for the desk we require 10 hours for woodworking and 3 hours for finishing. And the profit is $75. And the constraints are we have only 600 hours for woodworking. That means we can use only 600 hours or less. Then for finishing we can use the maximum 240 hours or less. And the objective is to maximize the profit. So the objective function is maximizing the objective function. The profit is 40x plus 75y, and this is what we are trying to maximize. Of course it is subject to the constraints, that is 5x plus 10y is the maximum you can use is 600 hours or less. Then 4x plus 3y, the maximum you can use is 240 hours, that is less or equal to 240 hours. Of course you have to produce 0 or more bookcases, and you have to produce 0 or more desks. That means x is greater or equal to 0. So we're going to take this constraints, we're going to convert it into graphic and get the feasibility region. So first is x has to be equal or greater than 0, that means above the x-axis. Y has to be greater or equal to 0, that means to the right of y-axis. Then we have to take 5x plus 10y equals 600 and graph a line. Then 4x plus 3y equals 240 and graph the other line. So here when x is 0, y is 60. So when x is 0, y is 60, that is 1 point. Then when y is 0, x is 120. And that is the first line. Then we need to graph 4x plus 3y equals 240. When x is 0, y is 80. And that is this point. When y is 0, x is 60. And that is 60, 0. And that is the other line. Then you have 5x plus 10y is less or equal to 600, means below this line. And 4x plus 3y less or equal to 240 means below this line. That means the feasibility region is above x-axis, to the right of y-axis, below this line and below this line. So this is the feasibility region. That means in the feasibility region, every point in the feasibility region is a profit. Then the maximum profit is at the corner of the feasibility region, and the minimum profit is also at the corner of the feasibility region. Then all we have to do is evaluate the objective function, which is profit equals 40x plus 75y at the corner points at 0, 0, at 0, 60, at 60, 0, and at 24, 48. But now, how do you get this 24, 48? To get this 24, 48, we need to solve 5x plus 10y equals 600 and 4x plus 3y equals 240 simultaneously. Then find what is x, what is y. You can do substitution method, or you can just put it in the calculator. Create a matrix called F, and that matrix is for x is 5, 4, for y is 10, 3, then augmented with 600, 240, then do ref F, then that is 1001, and the result is 2448. That is, this corner is 2448. Then evaluate the objective function, which is the profit 40x plus 75 at the corner points. So first evaluate it at 0, 0, that is 40. Profit equals 40 times 0 plus 75 times 0, that is 0. Then evaluated at 60, 0 at this point. Then profit equals 40 times 60 plus 75 times 0, which is 2400. Then evaluated at 24, 48. Then profit is 40 times 24 plus 75 times 48, that is 4560. Then evaluated at 0, 60, then the profit is 40 times 0 plus 75 times 60, which is 4500. So now here you have 0, 2400, 4560, and 4500, which is the maximum is 4560, and this is the absolute max. And this is when you produce 24 bookcases and 48 desks, then you will end up with the maximum profit. And the absolute minimum is 0. When you produce 0 bookcases and 0 desks, then you make nothing, it is 0. So that means you have x, y. X is bookcases, y is desks, is 24, 48. So when you make 24 bookcases and 48 desks, then your maximum profit is going to be 4560. That is, the carpenter shop will make a maximum profit of 4560 when 24 bookcases and 48 desks are produced and sold. And this is when you have 2 by 2 variable, you can do graphic method. But when it is 3 by 3 or 4 by 4 or 100 by 100 for that matter, or 1000 by 1000 like they do in Amazon, then doing solving graphic method becomes almost impossible. Then you have to use the other method, which is called simplex method. And the simplex method, you can use a calculator, but the best way to solve a simplex method is using Excel sheet. And that is what big businesses like Amazon, they use Excel sheet or some kind of programming to solve a multi-variable, could be 100 variable, 1000 variables, and that's what they use. In questions 21 to 25, we have done Gauss-Jordan Elimination, Reduced Row Echelon Form. We have seen manual solution. Now let's go back and verify our manual solution with technology TI-84+. For number 21, we'll create a matrix called A. The matrix is for X we have 2, 3, for Y 1, 2, augmented with 1 minus 2. And when we do ref A, we get 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal. That means X equals 4, Y equals minus 7. X equals 4, Y equals minus 7. And here it is. Okay, second matrix, edit A, it is 2 by 3, 2 by 3, and for X we have 2, 3, for Y we have 1, 2, augmented with 1 minus 2. Okay, so let's make sure our entry are correct. 2, 3, 1, 2, 1 minus 2. Then get out of here, second quit, second matrix A, and here it is 2, 3, 1, 2, 1 minus 2. Then do second matrix, math, go all the way down, ref, second matrix, call A, close it, hit enter, and the solution is 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 4 minus 7. That is X equals 4, Y equals minus 7. For number 22, we did Gauss elimination, row echelon form. That is 1 in the diagonal, 0 below the diagonal, and some number above the diagonal A, and augmented with BC. Then we create a matrix called B. For X is minus 2, 1, for Y 6 minus 3, augmented with 3, 6. We do ref B, then we get 1, 0, minus 3, 0, 0, 1, augmented with 0, 1. This means 0 times X plus 0 times Y equals 1. That is 0 equals 1, which is false, no solution. It is the same, 0 equals 19 and 0 equals 1 means the same thing. It is 0 equals some constant number, which is false. It is no solution. And here it is. So second matrix, edit, matrix B, it is 2 by 3. Okay. Then for X we have minus 2, 1. For Y we have 6 minus 3. 6 minus 3. 8. Augmented with 3, 8. Okay, let's make sure our entry are correct. Minus 2, 1, 6 minus 3, 3, 8. So second quit, second matrix, B, hit enter, so that is minus 2, 1, 6 minus 3, 3, 8. Then do second matrix, math, ref, second matrix, call B, close it, hit enter, and that is 1, 0, minus 3, 0, 0, 1. And that is X times 0 plus Y times 0 equals 1, which is 0 equals 1, which is false. That means no solution. Number 23, we did Gauss elimination, row echelon form. which is 1 in the diagonal, 0 below the diagonal, some number above the diagonal, A, and augmented with BC. So we create a matrix called C, 3 minus 2 for X, minus 9, 6 for Y, augmented with minus 6, 4. And we do RF C, and we get 1, 0, minus 3, 0, minus 2, 0. That means X times 0 plus Y times 0 equals 0. That is 0 equals 0. That means infinitely many solution. Then we call Y equals Y, which is an independent variable. Then X is going to depend on Y. That means X minus 3Y equals minus 2. That means X equals 3Y minus 2. That is infinitely many solutions. That the solutions are X is 3Y minus 2, Y is Y, where Y is from minus infinity to infinity. And here it is. Second matrix, edit, C, and it is 2 by 3. Then for X we have 3 minus 2, 3 minus 2. For Y we have minus 9, 6, augmented with minus 6, 4. Again, let's make sure our entry are correct. 3 minus 2, minus 9, 6, minus 6, 4. Then second quit, second matrix. It is matrix C. And here it is 3 minus 2, minus 9, 6, minus 6, 4. Then do second matrix, math, go all the way down, then go to RF, then call matrix C, second matrix C, and close the parenthesis. So that's equal to 1 minus 3 minus 2, 0, 0, 0. That means 0 times X plus 0 times Y equals 0, which is 0 equals 0. That is infinitely many solutions. Number 24, we did Gauss-Jordan elimination. We got the reduced row echelon form. We create a matrix called A, and the matrix is 2, 1, 3 for X, for Y minus 1 minus 2, 0, for Z 4 minus 10, 4, augmented with minus 3 minus 6, 7. 2, 1, 3, minus 1 minus 2, 0, 4 minus 10, 4, minus 3 minus 6, 7. Then we do RFA. We use fraction because we want to show this as a fraction. Then the result is 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal. That means X equals 3, Y equals 7, Z equals minus half. And here it is. Second matrix, edit, A. It is 3 by 4, 3 rows, 4 columns. For X we have 2, 1, 3. For Y we have minus 1, minus 2, 0. For z, we have 4 minus 10, 4. Augmented with minus 3, minus 6, 7. So let's make sure our entry are correct. Minus 3, minus 6, 7. 4 minus 10, 4. Minus 1, minus 2, 0. 2, 1, 3. Then get out of here, second quit. Second matrix. It is matrix A. And that is 2, 1, 3, minus 1, minus 2, 0, 4, minus 10, 4, minus 3, minus 6, 7. Then second matrix, math, go all the way down, RF, call matrix A, close it, hit enter, and here is the solution is 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal. That means x equals 3, y equals 7, z equals minus 0.5, which is minus half. Number 25, we solved linear programming graphic method, and we used matrix system to solve this corner, which is 24, 48. We created a matrix called F. For x, 5, 4. For y, 10, 3. Augmented with 600, 240. And when we did RFF, we got 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, which is x equals 24, y equals 48, which is this point. And here it is. Second matrix, edit, and we call it matrix F, and it is 2 by 3. For x we have 5, 4, 5, 4. For y we have 10, 3. 3, augmented with 600, 240. Okay, so let's make our entries correct. 5 for x, 5, 4. For y, 10, 3. Augmented with 600, 240. Then second quit, second matrix, matrix F, and here it is, 5, 4, 10, 3, augmented with 600, 240. Then second matrix, math, go all the way down to the RF, second matrix, called matrix F, close it, hit enter. Then you have 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, and augmented with 24, 48. That means x equals 24, y equals 48, and that is this corner. Here are more. Solve linear system of equations, Gauss-Jordan elimination, reduced row echelon form. We'll look at one solution, no solution, infinitely many solutions. For one solution, we'll have 1, 1, 1 in the diagonal, 0 above the diagonal, zeros below the diagonal, augmented with a, b, c. That is x equals a, y equals b, z equals c. And this is the reduced row echelon form. Number 1. Solve linear system of equations, two variables, Gauss-Jordan Elimination, reduced row echelon form, and it is one solution. And the system of equations are 1 over 5x plus 1 over 2y equals 6, 3 over 5x minus 1 over 2y equals 2. We'll create a matrix called A. For x we have 1 over 5 and 3 over 5. For y we have 1 over 2 and minus 1 over 2, augmented with 6, 2. And when we do ref A, we'll get 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 10, 8. That means x equals 10, y equals 8. And here it is. So we create a matrix A, 1 over 5, 3 over 5, half minus half, augmented with 6, 2. When we do ref A, we get 1 in the diagonals, 0 above the diagonal, 0 below the diagonal, augmented with 10, 8. That means x equals 10, y equals 8. Here it is. Second matrix, edit A, it is 2 by 3, 2 by 3. For x we have 1 over 5, and 3 over 5. For y we have 1 over 2 minus 1 over 2. Augmented with 6, 2. Okay, let's make our entry are correct. 6, 2, 0.5 minus 0.5, 0.2 minus 0.6. Then second quit, second matrix, A, and we'll call fraction, hit enter, and this will give you the matrix in fraction format. 1 over 5, 3 over 5, half minus half, augmented with 6, 2. Then we do second matrix, math, go all the way down, ref, second matrix, call A, close it, hit enter, and here it is, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 10, 8. That means x equals 10, y equals 8. Number 2, solve linear system of equations, two variables, Gauss-Jordan elimination, row reduced echelon form, no solution. And the system of equations are 4m minus 2n equals 3, 2m minus n equals 4. We create a matrix called B. For m we have 4, 2. For n we have minus 2, minus 1, augmented with 3, 4. And when we do ref B, we get 1, 0, minus half 0, 0, 1. That means m times 0 plus n times 0 equals 1. That is 0 equals 1. That means no solution. And here is a matrix B, 4, 2, minus 2, minus 1, 3, 4. RFB, we use fraction, so to display this as a fraction, so we get 1, 0, minus half 0, augmented with 0, 1. That means 0 times m plus 0 times n equals 1, which is 0 equals 1 means no solution. And here it is. Second matrix, edit B, that is 2 by 3. For m we have 4, 2. For n we have minus 2, minus 1. Augmented with 3, 4. Again, let's double check our entry. 3, 4, minus 2, minus 1, 4, 2. Then we second matrix B, and here it is 4, 2, minus 2, minus 1, 3, 4. Then we do second matrix, math, RF, second matrix, call B. Hit enter, and here is the solution. 1, 0, minus 0.5, which is minus half 0, 0, 1. That means m times 0 plus n times 0 equals 1, which is 0 equals 1. That means no solution. Number 3, solve linear system of equations, 2 variable, Gauss-Jordan Elimination, Reduced Row Echelon Form. And this is infinitely many solutions. The system of equations are 3r minus 12s equals 6, 2r minus 8s equals 4. We create a matrix called C. For r we have 3, 2. For s we have minus 12, minus 8, augmented with 6, 4. And when we do ref C, we get 1, 0, minus 4, 0, 2, 0. That means r times 0 plus s times 0 equals 0. That means 0 equals 0. That means infinitely many solutions. So let s to be an independent variable. S equals s. That means r minus 4s equals 2. Then solve for r. That means r is 4s plus 2. That means rs is 4s plus 2 and s. That is infinitely many solutions. And here it is. Second matrix, edit, we'll create a matrix called C. It is 2 by 3. For R we have 3, 2. For S we have minus 12, minus 8, augmented with 6, 4. Again, make sure our entry are correct. So 3, 2, minus 12, minus 8, 6, 4. Then second matrix, go to C, hit enter, and here it is 3, 2, minus 12, minus 8, 6 augmented with 6, 4. Then do second matrix, math, go all the way down, ref, call matrix C. Hit enter, and here is 1, 0, minus 4, 0, 2, 0. That means R times 0 plus S times 0 equals 0. That means 0 equals 0. That means infinitely many solutions. Let S be independent variable. Let S equals S. That means R minus 4S equals 2. That means R is 4S plus 2. That means RS is 4S plus 2S. Number 4 is solve linear system of equations, 3 variable, Gauss-Jordan Elimination, Reduced Row Echelon Form, and this is one solution. And the system of equations are x minus 2y plus 3z equals minus 4, 3x plus y minus z equals 0, 2x plus 3y minus 5z equals 1. We create a matrix called D. For x we have 1, 3, 2, for y minus 2, 1, 3, for z 3 minus 1 minus 5 augmented with minus 4, 0, 1. When we do ref D, we get 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal. That means x equals minus 1, y equals 6, z equals 3. And here is the matrix. This is matrix D. For x 1, 3, 2, for y minus 2, 1, 3, for z 3, minus 1, minus 5, augmented with minus 4, 0, 1. And when we do ref D, we get 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal. That means x equals minus 1, y equals 6, z equals 3. And here it is. So second matrix, edit, we're going to create matrix called D, and this matrix is 3 by 4, 3 by 4. For x we have 1, 3, 2, 1, 3, 2. For y we have minus 2, 1, 3. For z we have 3, minus 1, minus 5. Augmented with minus 4, 0, 1. Again, let's make our entry are correct. So we have minus 4, 0, 1, 3, minus 1, minus 5, 2, minus 2, 1, 3, 1, 3, 2. Then get out of here, second quit. Second matrix, go to D, hit enter. Here it is 1, 3, 2, minus 2, 1, 3, 3 minus 1 minus 5, minus 4, 0, 1. Then do second matrix, math, ref, second matrix, called D, Close it, hit enter, and here is the solution is 1 1 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 1 minus 1 6 3. That means x equals minus 1, y equals 6, z equals 3. Number 5 is solve linear system of equations, 3 variables, Gauss-Jordan elimination, reduced row echelon form, and this is no solution. And the system of equations are u plus v minus w equals 7, u minus v plus w equals 5, 3u plus v minus w equals minus 1. We create a matrix called E. For u we have 1 1 3, for v we have 1 minus 1 1, for w we have minus 1 1 minus 1, augmented with 7 5 minus 1. When we do RFE we get 1 0 0 0 1 0 0 minus 1 0 0 0 1. So the most important here to note is the last row is 0 0 0 1. That means 0 equals a constant, which is no solution. That is u times 0 plus v times 0 plus w times 0 equals 1. That is 0 equals 1. That means no solution. And here is the matrix E is 1 1 3, 1 minus 1 1, minus 1 1 minus 1, 7 5 minus 1. When we do RFE we have 1 0 0 0 1 0 0 minus 1 0 0 0 1. And here it is. Second matrix, edit, gonna go matrix E, and this is 3 by 4. For u we have 1 1 3. For v we have 1 minus 1 1. For w we have minus 1 1 minus 1. Augmented with 7 5 minus 1. So make sure our entry are correct. 1 1 3, 1 minus 1 1, minus 1 1 minus 1, augmented with 7 5 minus 1. Second quit, second matrix. Let's go to E, and that is 1 1 3, 1 minus 1 1, minus 1 1 minus 1, 7 5 minus 1. And we do second matrix, math, RF, second matrix called matrix E, close it, hit enter, and here is 1 0 0 0 1 0 0 minus 1 0 0 0 1. That means u times 0 plus v times 0 plus w times 0 equals 1. That is 0 equals 1. That means no solution. Number 6 is solve linear system of equations, 3 variable, Gauss-Jordan elimination, reduced row echelon form, infinitely many solutions. And the system of equations are q plus r plus s equals 1, q plus 2r plus 3s equals 4, 4q plus 5r plus 6s equals 7. We create a matrix called F. For q we have 1, 1, 4. For r we have 1, 2, 5. For s we have 1, 3, 6, augmented with 1, 4, 7. And when we do ref f, we get 1, 0, 0, 0, 1, 0, minus 1, 2, 0, minus 2, 3, 0. So what to notice here is the last row is 0, 0, 0, 0. That means q times 0 plus r times 0 plus s times 0 equals 0. That means 0 equals 0. That means infinitely many solutions. Let s be equals s independent variable. That means from the first row we have q minus s equals minus 2. That means q equals s minus 2. Then from the second row we have r plus 2s equals 3. That means r equals minus 2s plus 3. That means qrs is equal to q is s minus 2, r is minus 2s plus 3, and s is s. And here is the matrix F. 1, 1, 4, 1, 2, 5, 1, 3, 6, augmented with 1, 4, 7. And when we do ref f, we get 1, 0, 0, 0, 1, 0, minus 1, 2, 0, minus 2, 3, 0. And here it is. Second matrix, edit. We're going to create this time matrix F, and it is 3 by 4. For q we have 1, 1, 4. For r we have 1, 2, 5. For s we have 1, 3, 6. Augmented with 1, 4, 7. So once again, for q we have 1, 1, 4. For r1 we have 1, 2, 5. For s we have 1, 3, 6, augmented with 1, 4, 7. So second matrix, call matrix F, and here it is 1, 1, 4, 1, 2, 5, 1, 3, 6, 1, 4, 7. Then second matrix, math, go all the way down to ref. Second matrix F, close it, hit enter, and here it is 1, 0, 0, 0, 1, 0, minus 1, 2, 0, minus 2, 3, 0. That means 0, 0, 0, 0. Q times 0 plus R times 0 plus S times 0 equals 0. That is 0 equals 0. That means infinitely many solution. And that is S is independent variable. S equals S. Then from the first row we have Q minus s equals minus 2. That means q equals s minus 2. From the second row we have r plus 2s equals 3. That means r equals minus 2s plus 3. Number 7 is solve linear system of equations, 4 variables, Gauss-Jordan elimination, reduced row echelon form, 1 solution. And the system of equations are x plus y plus z plus w equals 2, x plus 2y plus 2z plus 4w equals 1, minus x plus y minus z minus w equals minus 6, minus x plus 3y plus z minus w equals minus 2. We create a matrix called G. For x we have 1, 1, minus 1, minus 1. For y we have 1, 2, 1, 3. For z we have 1, 2, minus 1, 1. For w we have 1, 4, minus 1, minus 1. Augmented with 2, 1, minus 6, minus 2. And when we do RFG, we get 1, 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 1 minus 2, 4 minus 1. That means x equals 1, y equals minus 2, z equals 4, w equals minus 1. And we create a matrix in calculator. It is 1, 1, minus 1, minus 1, 1, 1, minus 1, minus 1, then 1, 2, 1, 3, 1, 2, 1, 3, 1, 2, minus 1, 1, 1, 2, minus 1, 1, 1, 4, minus 1, minus 1, 1, 4, minus 1, minus 1, augmented with 2 1s minus 6 minus 2. 2, 1, minus 6, minus 2. And when we do RFG, we get 1, 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 1, minus 2, 4, minus 1. That means x equals 1, y equals minus 2, z equals 4, and w equals minus 1. And here it is. Second matrix. Edit. G. It is 4 by 5. 4 by 5. For x we have 1, 1, minus 1, minus 1. For y we have 1, 2, 1, 3. For z we have 1, 2, minus 1, 1. For w we have 1, 4, minus 1, minus 1. Augmented with 2, 1, minus 6 minus 2. Okay, let's make our entries are correct again. 2, 1, minus 6 minus 2. 1, 4, minus 1 minus 1. 1, 2, minus 1, 1. 1, 2, 1, 3. Then 1, 1, minus 1, minus 1. Then second quit, second matrix, go to G, and here it is 1, 1, minus 1, minus 1, 1, 2, 1, 3, 1, 2, minus 1, 1, 1, 4, minus 1, minus 1, augmented with 2, 1, minus 6, minus 2. And we do second matrix, math, go all the way down, RF, second matrix, called G, close it, hit enter, and here is 1, 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 1 minus 2, 1, 4. That means x equals 1, y equals minus 2, z equals 4, and w equals minus 1. Number 8, solve linear system of equations, 4 variables, Gauss-Jordan Elimination, Reduced Row Echelon Form, 1 solution. And the system of equations are minus 2q plus 2r plus 2s minus 2t equals minus 10. Q plus r plus s plus t equals minus 5. 3q plus r minus s plus 4t equals minus 2. Q plus 3r minus 2s plus 2t equals minus 6. We create a matrix called H. For Q we have minus 2, 1, 3, 1. For R we have 2, 1, 1, 3. For S we have 2, 1, minus 1, minus 2. For T we have minus 2, 1, 4, 2. Augmented with minus 10, minus 5, minus 2, minus 6. And when we do RF H, we get 1, 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 1, minus 3, minus 2, minus 1. That means Q equals 1, R equals minus 3, S equals minus 2, T equals minus 1. And here is, we create a matrix H in the calculator, which is minus 2, 1, 3, 1 for Q. For R, 2, 1, 1, 3. For S, 2, 1, minus 1, minus 2. For T, minus 2, 1, 4, 2. Augmented with minus 10, minus 5, minus 2, minus 6. And when we do RF H, we get 1, 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with 1, minus 3, minus 2, minus 1. That means Q equals 1, R equals minus 3, S equals minus 2, t equals minus 1. And here it is. Second matrix, edit, go all the way down H, and this is 4 by 5. 4 by 5. For Q it is minus 2, 1, 3, 1. For R it is 2, 1, 1, 3. For S it is 2, 1, minus 1, minus 2. For T, minus 2, 1, 4, 2. Augmented with minus 10, minus 5, minus 2, minus 6. Again, let's make our entries are correct. So it is minus 10, minus 5, minus 2, minus 6. Minus 2, 1, 4, 2. Two, 1, minus 1, minus 2. 2, 1, 1, 3. Minus 2, 1, 3, 1. Second quit, second matrix. It is H. Here it is, minus 2, 1, 3, 1. 2, 1, 1, 3. 2, 1, minus 1, minus 2. Minus 2, 1, 4, 2. Augmented with minus 10, minus 5, minus 2, minus 6. And we do second matrix, math. Go all the way down to RF. Second matrix, call H. Close it, hit enter, and that is 1, 1, 1, 1 in the diagonal, 0 above the diagonal, 0 below the diagonal. That means Q equals 1, R equals minus 3, S equals minus 2, T equals minus 1. Number 9. Solve linear system of equations, 4 variables, Gauss-Jordan Elimination, Reduced Row Echelon Form, 1 solution. And the system of equations are K plus L plus M plus N equals minus 2, minus 3K minus 2L plus 3M plus 2N equals 10, 2K plus 3L plus 2M minus N equals minus 12, 2K plus 4L minus M plus N equals 1. We create a matrix called I. For K, it is 1, minus 3, 2, 2. For L, it is 1, minus 2, 3, 4. For M, it is 1, 3, 2, minus 1. For N, it is 1, 2 minus 1 1. Augmented with minus 2 10 minus 12 1. And when we do RFI, we get 1 1 1 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with minus 4 1 minus 2 3. That means K equals minus 4, L equals 1, M equals minus 2, N equals 3. And here is the matrix we create in the calculator. It is 1 minus 3 2 2, 1 minus 2 3 4, 1 3 2 minus 1, 1 2 minus 1 1, augmented with minus 2 10 minus 12 1. And when we do RFI, we get 1 1 1 1 in the diagonal, zeros above the diagonal, zeros below the diagonal, augmented with minus 4 1 minus 2 3. That means K equals minus 4, L equals 1, M equals minus 2, N equals 3. And here it is. Second matrix. Edit, create matrix I, and it is 4 by 5. For K we have 1 minus 3 2 2. For L, it is 1 minus 2 3 4. For M, it is 1 3 2 minus 1. For N, it is 1 2 minus 1 1. Augmented with minus 2 10 minus 12 1. So let's make our entries are correct. So it is minus 2 10 minus 12 1, 1 2 minus 1 1, then 1 3 2 minus 1, 1 minus 2 3 4, 1 minus 3 2 2. Second quit, second matrix, it is I, hit enter, and here it is 1 minus 3 2 2, 1 minus 2 3 4, 1 3 2 minus 1, 1 2 minus 1 1, augmented with minus 2 10 minus 12 1. Then second matrix, math, go all the way down to RF, second matrix, I, close it, hit enter, And here is the solution. 1 1 1 1 in the diagonal, 0 above the diagonal, 0 below the diagonal, augmented with -4 1 -2 3. That means K equals -4, L equals 1, M equals -2, N equals 3. Notice so far I have been using different letters to show that it doesn't matter what letter you use. You can use any letters, so that's why I've been using different letters to demonstrate that you can use any letters. Number 10, solve linear system of equations, 10 variables, Gauss-Jordan Elimination, Reduced Row Echelon Form, 1 solution. Solve manually and verify with TI-84 plus matrix, which is technology. This is special design. I special designed this so we can solve this manually. And here are the equations, system of equations. Equation number 1, 2k plus L plus M plus N plus Q plus R plus S plus T plus V plus W equals 56. Notice there are 10 variables here. Then K plus 2L plus M plus N plus Q plus R plus S plus T plus V plus W equals 57. Then K plus L plus 2M plus N plus Q plus R plus S plus T plus V plus W equals 58. Then K plus L plus M plus 2N plus Q plus R plus S plus T plus V plus W equals 59. Then equation 5 is K plus L plus M plus N plus 2Q plus R plus S plus T plus V plus W equals 60. Equation 6 is K plus L plus M plus N plus Q plus 2R plus S plus T plus V plus W equals 61. Equation 7 is K plus L plus M plus N plus Q plus R plus 2S plus T plus V plus W equals 62. Equation 8 is K plus L plus M plus N plus Q plus R plus S plus 2T plus V plus W equals 63. Equation 9 is K plus L plus M plus N plus Q plus R plus S plus T plus 2V plus W equals 64. Equation 10 is K plus L plus M plus N plus Q plus R plus S plus T plus V plus 2W equals 65. Now notice in the diagonal you have 2K, 2L, 2M, 2N, 2Q, 2R, 2S, 2T, 2V, 2W. And above the diagonal you have ones, and below the diagonal you have ones. And notice these are 56, 57, 58, 59, 60, 61, 62, 63, 64, 65. So to solve this manually, first we need to add equation number 1 through 10 and call them equation 11. So you have K, 9Ks plus 2K is 11K. 9Ls plus 2L is 11L. 9M plus 2M is 11M. 9N plus 2N is 11N. 9Q plus 2Q is 11Q. 9R plus 2R is 11R. 9S plus 2S is 11S. 9T plus 2T is 11T. 9V plus 2V is 11V. 9W plus 2W is 11W. And here we have 64 plus 56 is 120. 63 plus 57 is 120. 62 plus 58 is 120. 61 plus 59 is 120. 4 times 120 is 480, plus 60 is 540. 540 plus 65 is 605. This is equation 11. Then from here we can factor out 11. Then 11 open parenthesis k plus m plus n plus n plus q plus r plus s plus t plus v plus w equals 605. And divide both sides by 11, then you have k plus l plus m plus n plus q plus r plus s plus t plus v plus w equals 650 divided by 11 is 55. Okay, now to solve manually, you have compare equation number 1 to equation number 13. They are the same except equation number 1 has one extra k. That means equation number 1 is k plus equation number 13. That is, it is k plus 55. Equation number 13 is 55. And it is equal to 56. That means k equals 56 minus 55. K is equal to 1. Then compare equation 2. Compare equation 2 to equation 13. They are the same except equation 2 has one extra L. That means equation 2 is L plus equation 13. And that is, it is L plus 55. Equation 13 is 55. And it is equal to 57. That means L is equal to 57 minus 55. L equals 2. Then compare equation 3 to equation 13. They are the same except equation 13 has one extra m. That means equation 13 is m plus 55. Equation 13 is 55. And it is equal to 58. That means m equals 58 minus 55, which is m equals 3. Then compare equation 4 with equation number 13. They are the same except equation number 4 has one extra n. That means equation 4 is n plus 55. And it is equal to 59. That means n is 59 minus 55. N equals 4. Then compare equation 5 with equation 13. They are the same except equation 5 has one extra q. That means equation 5 is q plus 55 and it is equal to 60. That means q equals 60 minus 55. Q equals 5. Then compare equation 6 to equation 13. They are the same except equation 6 has one extra r. That means equation 6 is r plus 55. And it is equal to 61. That means r equals 61 minus 55. R is equal to 6. Then compare equation 7 to equation 13. They are the same except equation 7 has one extra s. That means equation 7 is s plus 55 and it is equal to 62. That means s equals 62 minus 55, s equal to 7. Then compare equation A to equation 13. They are the same except equation 8 has one extra t. That means equation 8 is t plus 55 and it is equal to 63. That means t equals 63 minus 55, which is t equals 8. Then compare equation 9 to equation 13. They are the same except equation 9 has one extra v. That means equation 9 is v plus 55 and it is equal to 64. That means v is equal to 64 minus 55. That is v equals 9. Then compare equation 10 to equation 13. They are the same except equation 10 has one extra w. That means equation 10 is w plus 55 and it is equal to 65. That means w equals 65 minus 55, w equals 10. That means the solution are k equals 1, l equals 2, m equals 3, n equals 4, q equals 5, r equals 6, s equals 7, t equals 8, v equals 9, w equals 10. So that is the manual solution. Now we're going to use the technology. We're going to create a matrix called J. And the matrix is 10 by 11, 2's in the diagonal, 1 above the diagonal, 1 below the diagonal, augmented with 56, 57, 58, 59, 60, 61, 62, 63, 64, 65. And when we do RFJ, we get 1's in the diagonal, 0 above the diagonal, 0 below the diagonal. That means k equals 1, l equals 2, m equals 3, n equals 4, q equals 5, r equals 6, s equals 7, t equals 8, v equals 9, w equals 10. And we verify this in the calculator. So we create a matrix J, 2's in the diagonal, 1's above the diagonal, 0's below the diagonal, and augmented with the numbers all the way to 65. When we do RFJ, we get 1's in the diagonal, 0's above the diagonal, 0's below the diagonals, and augmented with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here it is. We create a matrix, second matrix, edit, call it matrix J, and it is 10 by 11. So the entries are 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Then 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 1. Then 1, 1, 2, 1, 1, 1, 1, 1, 1, 1. Then 1, 1, 1, 1, 1 1 2 1 1 1. Then 1 1 1 1 2 1 1 1 1 1. Then 1 1 1 1 2 1 1 1 1 1. Then 1 1 1 1 1 1 2 1 1 1. Then 1 1 2 1 1 1 1 1 1 1. Then 1 1 1 1 1 1 1 1 2 1 then 2 1 1 1 1 1 1 1 1 1. Then it's augmented with 65 64 63 62 61 60 59 58 57 56. So let's make our entries are correct. So we have 56, 57, 58, 59, 60, 61, 62, 63, 64, 65. Then we have 2's in the diagonal and 1's above and below the diagonal. So second quit, then second matrix J, hit enter, and here it is 2 2 2 2 2 2 2 2 2 2 2's in the diagonal, 1's above the diagonal, and all the way to 66. Then do second matrix, math, go all the way down to RF, second matrix, go all the way to J, close it, hit enter, and here is the solution. 1 1 1 1 1 in the diagonal, zeros below the diagonal and 0 above the diagonal, and it is 1 1 all the way. Then the solution is 10 9 8 7 6 5 4 3 2 1, and those are the solutions. And that's the verification using the technology TI-84 Plus. And thank you. Please subscribe, share and like, and ask your friends to subscribe, share and like.
Mama,